Hello and welcome to 4th grade Unit 7 Notes. This unit we're going to talk about fractions and decimals. Make sure you have your note sheet and be ready to take some extra notes and work on some extra practice problems. Here we go. The first thing we're going to talk about is comparing fractions. When we compare fractions, there's a couple things we can look at first. The first thing we want to look at is if the numerators or the top numbers are the same. If the numerators are the same, but the denominators, the bottom, are different, then we want to find the denominator that is the smallest, because that means we would have broken our whole into a least amount of pieces, so our pieces would be bigger. If we have a common denominator, bottom number, but a different numerator, top number, then we want the numerator that is the biggest, because that means we would have the most pieces out of that whole. But sometimes we're going to have problems that look like this one, where we have a different numerator and denominator. So in this case, we need to find, in math terms, what we call the LCM, which is the least common multiple. Multiples are our count by numbers. So if we have a denominator of 4 and a denominator of 6, we're going to start looking at our count bys until we can find a count by that is similar in both. So if I look at my 4, I have a count by 4, and then I have 8, and then I have 12. Now I can stop at 12 because I already know that 6 can become 12, because I have 6 and then I have 12. So 12 is my LCM, my least common multiple, the smallest multiple that both of these numbers share. With that, we can then change or convert our fractions to have a common denominator. So we have to look at how many times did I multiply 4 by to get to 12? And the answer is 3. What we do to a bottom of a fraction, we must do to the top also to keep the fractions equivalent. So 3 times 3 is 9, and 4 times 3 is 12. So we converted our left side fraction. Now we need to go and convert our right side fraction. What times 6 gets us to 12? We know that it's 2. What we do to the bottom, we do to the top. So we're going to get 5 times 2, which is 10, over 6 times 2, which is 12. Now we have a common denominator, so we can compare our two fractions. If I have 9 pieces out of 12, or I have 10 pieces out of 12, 10 pieces would be more than the 9 pieces. So now we can compare those fractions. Moving on to simplifying fractions. In simplifying fractions, we're going kind of the opposite order. We're trying to get our fractions smaller. So instead of multiplying, we're going to be dividing. So the first step we need to do is find the GCF. The GCF stands for greatest common factor. Now remember, a factor are two numbers that, when multiplied, they get to the product of the number we're looking at. So if we're looking at 36, what two numbers multiplied together get us to 36? Well, I know 1 and 36 do. I know that 2 and 18 do. I know that 3 and 12 do. And I know that 4 and 9 do. And I worked my way from outside to inside. Now I'm going to do the same thing with my 96. With 96, I know that 1 and 96 work. I know that 2 and 48 work. I know that 3 and 32 work. I know that 4 and 16 work. I know that 6 and 12 work. And I know that 8 works. So if I'm finding my least common multiple, I am going to find that it is 12 in both of these cases. So if I divide 36 by 12, I will get 3. And if I do 96 divided by 12, I get 8. And so my most simplified fraction is 3/8. And I know this is the most simplified because 3 is a prime number. It can only be divided by 1 and itself. Moving on to our next concept, equivalent fractions. Equivalent fractions are going to find fractions that mean the same amount. We can do this by multiplying or dividing. So if I look at my example here, I have 1/5. Somehow I got to 25. So what times 5 got me to 25? I know that the answer is 5. So what I do to the bottom, I also do to the top. So 1 times 5 gets me 5. We can also look at the top. 1 times what got me to 4? I know that it is 4. So then 5 times 4 gets me my bottom, which is 20. 1 times 2 is what I did on top to get the top. So then 5 times 2 will get me my bottom of 10. So what you do to the top, you do to the bottom. For these fractions, you always want to start on the front fraction and go to any of the back or further fractions. This is not on your note sheet, so this would be extra notes that you might want to copy into your notebook. Feel free to pause the video at any time to write these in. Decimal place values to the hundredths place value. Notice that THS. The THS stands for after the decimal. So anytime we have numbers after the decimal, we would end up with that THS at the end of it. Standard form just means we would write it in our normal form with numbers. So this one is 13.45. If I wanted to write it in expanded form, there are 2 different ways that you can write it. The first one would say 1 times 10 because the 1 is in the tens place, plus 3 times 1 because the 3 is in the ones place value, plus 4 times 1/10 because the 4 is in the tenths place value, plus 5 times 100 or 5 times 1/100th because 5 is in the hundredths place value. The other way we can write it is just by expanding out each number. Notice after the decimal, we can only do 1 digit at a time, so 0.4 and then 0.05, keeping the places or the numbers in their correct place value. The last thing down there is word form. Anything that is a whole number will go in front of the word and. And means decimal. So we had 13 as a whole number, so 13, and then we have the decimal, so and we have 45, and we can come up with what it would be as a fraction or what place value by putting the 1 under the decimal and putting zeros under each place value. So in this case, I can see that it is in the hundredths place, so 45 hundredths. Remember, just like whole numbers, if I have a ones to tens digit, I need to put that hyphen in the middle of it. All right, converting fractions to decimals. The first step to do is count how many zeros are in your denominator. So I have 1 is my decimal point, and I had 3 zeros. So I'm going to draw 3 lines after the decimal. Step 2 says we place the last digit into the last underlined digit. And then everything in front of it goes in front. Any missing spaces would be filled in with zeros. Keep in mind, fractions are just division problems. So you can write out a division problem. So for this one, we would have the inside number 18 and the bottom number, outside number, is on the outside of a division bar. So we could go out and divide this problem out. Let's convert some in examples. All right, so we have 10, so it's a decimal, and 1 0. And the 8 goes right into that one spot. We're going to put a 0 out front to hold the place because we don't have any whole numbers here. This next one says 100, so a decimal for the 1, and we have 2 zeros in 100. The 7 goes into the last place value, and then we fill in with zeros. The last one here is a little bit more tricky. We do have a whole number in this case. So 4 is going in front of the decimal. We have 3 zeros after the decimal. And the last digit goes into the last space, filling in any in front of it. And now we have an empty hole here. So we're going to put a 0 as a placeholder there. So that is how easy it is to convert decimals when the bottom number is a power of 10. Rounding decimals. We're going to round decimals by doing a couple steps. Practice these steps because they're really going to help you understand. So the first thing is we're going to round to the nearest tenth. If I write out 10, I put a decimal under the 1, and I underline the first 0. So the number I'm going to underline here is the 4 in this first one. The digit behind it tells it what to do. 5 says go up. So the 4, the underlined value, is going to go up by 1. Everything in front of it stays the same. Everything behind that underline goes away. We don't put anything in its place. All right, let's take a look at our next answer. The 7 is in our tenths. The 3 tells it what to do. A 3, according to rounding rules, says to stay. So the 7's going to stay a 7. The 8 stays, and nothing happens after our underlined digit. So our answer is 8.7. Our next one, we underline the 9. The 6 tells it to go up. This one's a little tricky. So the 9 becomes a 10. The 0 goes here. We add +1 to the place value next door, just like any other addition. And then any digit in front of it stays the same. So this one's going to be 22.0. Now it's your turn to try. Try these practice problems. Rewatch the video at any point if you're feeling stuck, and resume the video to see the answers. All right, here's the answers. So 1/5 is smaller than 2/5. 3/6 is larger or greater than 3/7. 9/12 is less than 9/10. And 8/9 is greater than 6/9. For problem number 2, if I found my GCF, greatest common denominator, or greatest common factor, I would find out that the biggest factor, both 32 and 64 share, is 32. And I get an answer of 1/2 when I divide both top and bottom by 32. Number 3, to get from 4 to 20, we timesed it by 5. So what we do to the bottom, we do to the top. 1 times 5 is 5. The next one, to get to 6 from 1, we times by 6. What we do to the top, we do to the bottom. So 4 times 6 is 24. And to get from 1 to 2, we times by 2. So 4 times 2 is 8. Rounding to the nearest tenth, the 6 is in the 10th spot. The 1 tells it what to do, and it says to stay. So our 25 stays and our 0.6 stays. Everything else goes away. And our last one, Jack wrote a number, 94. 94. Let's change that. That should be a 94. Let's erase and make it even better. All right, we have a 94. And the word "and" meant decimal point, 529. So if I write 529 and then I write the place value amount, 1,000. So I put it over 1,000. There are 3 zeros in 1,000. So I have 3 numbers after the decimal. The 9 goes into the last, the 2 and the 5 go in front of it. Rewatch the video if you need any extra help or explanation. Otherwise, good luck.